Just learned about heat and how to calculate heat of exchange between system, solid and liquid state. Now, how this heat transfer, how this heat is going from one system to another. So there are three kinds of heat transfer: conduction, convection, and radiation. So radiation, basically, that's how we receive heat from sun, electromagnetic waves. The convection, that's what deal with fluids. We will talk today but just about conduction. So basically, conduction is required system in contact to each other, so in solid contact. So we need two systems, one at hot temperature, not one at cold temperature, at lower temperature. So one hot reservoir. So reservoir, basically, when you hear the word reservoir, it means that this system, it maintains the temperature. And a cold reservoir, so it maintains this temperature. So there is an insulation, basically. Okay, but it allows the heat to transfer from this hot reservoir to cold reservoir through slab. Here, one slab. So that's a rectangular shape. Then we see just cross section. That's a rectangular shape of thickness L, of cross-sectional area A. So if you want to draw it, we might draw it like that. That's our slab. So it has a certain thickness L, and it has cross-sectional area A. Okay? And we have a heat flow through this slab from the hot reservoir to the cold reservoir. So how this heat is transferred through this slab? And we are interested in what is the rate of energy transfer. Basically the power. So what is the power? The heat transferred during a certain time. What do you think it depends on? It depends on the difference in temperature, of course. If we have more hot body and more cold body, we will have more energy transfer. It isn't. So the rate by which it is transferred depends on the difference between the two temperatures. The more the difference is greater, the more the energy is transferred fast. Increase the area of contact between the slab and the two systems. So that's the area in common. If I increase this area, there will be more heat transferred. So this should be proportional to the area. What about the length, the thickness? If I increase the thickness, do you think that there will be more heat or less heat? If I increase the thickness of the slab, of course it will take longer to transfer. So this is inversely proportional to the length. Okay. And we are done, basically. There is just another term, K, which tell me which kind of slab is that? What is it made of? So that's thermal conductivity. K is a thermal conductivity. Okay. What is the unit of rate? What do you think? That joule, that's energy per second. What's that? It's what? It's power, basically. So what is the unit of thermal conductivity? We can deduce it. So that's watt meter per meter squared. Difference in temperature, let's express it in Kelvin. So in other words, that's watt per meter Kelvin. That's the unit for thermal conductivity. So most of the problem, what we can ask you, just simple use of this formula. In some problem, we have two slabs made of two different material, having two different thermal conductivity and two thicknesses, let's say same area, same cross-sectional area, simplify a lot of things. So what we can say about the heat transfer, the rate by which the heat is transferred? Well, we have first system, second system, and two slabs in contact to each other. So the heat, what do you think the heat will be? The heat transfer is the same. It's the same. So let's assume that, so I know this temperature at this wall, I know the temperature at this wall, but I don't know the temperature at the section shared between the two slabs. So Tx is unknown. But I can write the rate of change, which is the same, is equal to what? The rate of change from the first slab. So we just write it, K2, cross-sectional area. The difference in temperature, what is difference in temperature? Th, the hotter one, minus the cold one, Tx, over the thickness, L2. And this is equal to what? The transfer through the second slab, K1, A, the difference in temperature, hot one, Tx, minus Tc, over L1. You can write this. And from this you can deduce Tx. Once I derive it, I plug it in again to get the formula for P. So if you do it, you get this formula for Tx. If you solve this for Tx, you get this formula. If you plug this into the power, you will get this one. That's area times Th minus T cold, T cold, that's difference in temperature, the total difference in temperature, divided by what? L1 over K1 plus L2 over K2. That's the formula that we use when we have two slabs. What do you think what we use when we have n slab? Instead of 2, we have 3 or 4 or more. That's the same formula. Area times difference in temperature divided by what? The sum of thickness divided by thermal conductivity. Okay? That's basically what we call the thermal resistance. Alright, so the sum of the thermal resistance. So that's all what you need to know about